Howdy, y'all. It's me, Mr. B. Okay, first of all, repeat after me. Minerals make rocks. Rocks do not make minerals. Okay, now remember that everything that exists is made up of atoms. The tiniest part of anything that exists is an atom. Atoms are the tiny particles that make up all matter, and since minerals are matter, they're made of atoms. Now, a mineral is a naturally occurring inorganic solid that has a definite chemical composition and an orderly crystal structure. So what does naturally occurring mean? It means that minerals are made by nature, not man. Inorganic means that minerals are not alive and have never been alive. Solid, well, duh. The definite chemical composition part means it has an exact recipe. It will always have the same chemicals in it. And the orderly crystal structure part means that atoms are made that make up the mineral are arranged in a specific pattern, kind of like a snowflake. Minerals can be elements such as gold, but most are compounds such as salt, which is made up of two elements, sodium and chlorine. Now, there are two main types of minerals. There are silicates and non-silicates. Silicate minerals always contain both silicon and oxygen. By far, silicates form the most minerals on Earth because 90% of the Earth's crust is made up of silicate minerals, and silicon and oxygen are the two most common elements in the Earth's crust. Okay, the most common silicate minerals are quartz, mica, and feldspar. The pink stuff in granite, that's feldspar. Non-silicate minerals do not contain combinations of oxygen and silicon, and they make up less than 10% of the Earth's surface. Examples of non-silicates include things such as gold, silver, copper, salt, and gypsum. Let's talk about how we can identify different minerals. We'll use the physical characteristics to help tell them apart. There are 6 physical characteristics that we're going to examine. They are color, luster, streak, cleavage, hardness, and density. A physical characteristic can be observed without changing the item being examined. First of all, color. Well, we know what color is, but color is not always an accurate way to identify a mineral because air, water, mud, even chemicals in the air might change the color of the mineral. So instead of color, we like to use streak. Now, streak is the color of the powdered mineral. We get the streak by rubbing the mineral against a streak plate. Remember, the streak plate is a small piece of tile and can be black or white. Many minerals have a specific color that's going to show up. We can also use luster. Luster is how the mineral reflects light. A mineral can have a metallic luster, which means it's real bright and shiny, kind of like gold or silver. Minerals may have a submetallic luster, which is slightly shiny to not shiny, and a piece of quartz like this, it may be submetallic. And finally, we may have the minerals like this graphite that are dull and not shiny at all. The way a mineral breaks is also a good way to identify it. Minerals either have fracture or cleavage. How minerals break depends on their crystalline structure. In other words, how the crystals fit together determines how they're going to break. When a mineral breaks raggedly or unevenly, like this chunk of quartz, we call it fracture. Some minerals are going to break very smooth, maybe even in real thin layers. Okay, remember this mica that we passed around? It has cleavage, and the quartz has fracture. Now, hardness is a well-known way of testing minerals. Hardness is a mineral's resistance to being scratched. Some minerals are very soft and can be scratched with your fingernail, while diamonds, the hardest, they cannot be scratched by anything except another diamond. In fact, there's even a scale. It's called the Mohs Scale. The Mohs Scale lists the hardness of minerals from 1 to 10. The softest minerals have the lowest numbers. Number 1 is talc. You can scratch talc with your fingernail very easily. Number 2 is gypsum. You can barely scratch gypsum with your fingernail, but you can. Number 3 is calcite. Now, calcite will scratch your fingernail, but you can't scratch calcite. We can scratch a penny with calcite. Number 4 is fluorite. It's about as hard as a nail. Number 5, apatite. Hard enough, almost as hard as a piece of glass. 6 is feldspar, and it's so hard you can scratch glass and a metal file. 7 is quartz. We know that quartz is very hard, and we can actually scratch a piece of steel with it. 8 is topaz. So topaz will scratch quartz, but quartz won't scratch topaz. Number 9 is corundum. It's so hard that we use it to make saws for cutting metal. And number 10 is diamonds. We all know that diamonds are the hardest minerals around, and they will scratch anything, but nothing can scratch them. So remember, a mineral is a naturally occurring inorganic solid that has a definite chemical composition and an orderly crystal structure. There are 6 physical properties of minerals: hardness, luster, streak, cleavage, fracture, and density. Hardness measures how easily a mineral can be scratched. Numbers from 1 to 10. Our friend Frederick Mohs came up with the Mohs Scale that lists 10 minerals. Luster describes the way a mineral reflects light. It can be metallic, non-metallic, or submetallic. Streak is another property. It gives us the color of the powder on a streak plate. Cleavage is how the minerals break nice and smooth on flat surfaces. Mica has cleavage, and quartz has fracture, breaks ruggedly. Okay, ta-ta for now. See you later.